Water is one of the main components of blood. In a healthy individual, blood is normally composed of 45% red blood cells, also known as erythrocytes. The portion of the blood that is erythrocytes is known as the hematocrit. Less than 1% of blood is made up of white blood cells, which is also known as the buffy coat. The fluid portion of the blood is known as the plasma and makes up approximately 55% of the blood. Plasma consists of ions, nutrients, waste products, hormones, and anything else in the blood that is not a cell, all being circulated in water. Therefore, in normal circumstances, over 50% of blood is made up of water. In order to understand how the kidneys regulate blood pressure, it is important to understand what aspects of blood pressure and what components of the blood the kidneys are able to act on. Let us review the factors that affect blood pressure. Mean arterial pressure, or blood pressure, can be affected by the variables in the following formula. Blood pressure is determined by the flow rate, meaning how quickly the blood is flowing through the body, or how much blood flows per minute. Blood pressure is also determined by the volume of blood, meaning how much blood is in the body. And lastly, blood pressure can be regulated by resistance to blood flow. This formula for blood pressure is discussed in greater detail in the video on this channel on mean arterial pressure. The kidneys regulate blood pressure by affecting the volume of blood and by affecting the resistance to blood flow. The one way in which the kidneys do not regulate blood pressure is through the flow rate. The kidneys do not increase or decrease the heart rate to increase or decrease the rate at which blood flows per minute through the body. Thus, the renin-angiotensin-aldosterone system regulates blood pressure by regulating the volume of blood in the body and by regulating the resistance to blood flow. Number 3. The kidneys can reabsorb water and ions into the blood. The kidneys filter blood at what is known as the glomerulus. The glomerulus is a capillary network that is contained in the nephrons of the kidneys. Each kidney has hundreds of thousands of nephrons. The blood is supplied to the glomerulus by the afferent arteriole. Blood leaves the glomerulus at the efferent arteriole. It is as blood is flowing through the glomerulus that much of the plasma is filtered out of the blood and into the kidneys. This filtration is caused by the blood pressure in the glomerulus as blood flows through the glomerulus. The plasma that has left the blood during filtration now circulates through the nephron from the proximal convoluted tubule to the loop of Henle, to the distal convoluted tubule, and lastly, the medullary collecting duct. It is at the medullary collecting duct that the renin-angiotensin-aldosterone system is able to work to increase blood pressure. This is because as the filtrate passes through the nephron, much of it is being reabsorbed. When the filtrate reaches the medullary collecting duct, it is the last chance for the filtrate to be reabsorbed before leaving the kidneys for the urinary bladder. The renin-angiotensin-aldosterone system increases the amount of filtrate that is reabsorbed at the medullary collecting duct, leading to an increase in water and ion reabsorption into the blood. To understand how the renin-angiotensin-aldosterone system plays a role in the reabsorption of filtrate at the medullary collecting duct, it is important to review what stimulates production of angiotensin II and the effects angiotensin II has on the body.